Hi everyone. So this lesson we are going to find the sum of geometric sequence. The first step involves finding the proof of finding the formula. So the formula we use in order to find the sum of geometric sequences Sn is equal to a times of 1 minus r to the power of n divided by 1 minus r. So first let's look at this example here. So look at this geometric sequence, which is 3, 6, 12, and so on. So the first term is 3 and the common ratio is 2 here. So when we write it as the first term, which is 3, 6, 12, and so on, this represents a geometric sequence. But when we add the terms, like in the second step, you can actually see it's 3 plus 6 plus 12 and so on. We call it as the geometric series. And we represent the geometric series as Sn. So let's look at the proof. Let's do the proof for the formula. So when we write the general geometric sequence, so the general geometric sequence is given as a comma a times r. The first term is represented as a, second term is the first term multiplied by the common ratio ar square and ar cube and up to ar to the power of n minus 1. So this is representing the general form of a geometric sequence. How do we write in terms of series? So when we represent the geometric series, we use the symbol Sn. So Sn is equal to a plus ar plus ar square plus ar cube and up to ar to the power of n minus 1. So this represent, we'll just take this as the first equation, and now we will multiply this equation with r. So when you multiply this whole equation with r, you get r times of Sn is equal to ar plus ar square plus ar cube and so on. So this will be ar to the power of n. So now when we actually subtract the second equation with the first one, so when we actually subtract Rsn minus Sn, what do we get? So when we actually subtract it, we're only left with minus a plus ar to the power of n, because all the other terms just gets cancelled, because ar minus ar is 0, ar square minus ar square will be 0, so we're just left with the term minus a plus ar to the power of n. Now what we do, we just take the Sn common out. So the common factor is Sn here on the left hand side. So Sn times r minus 1 is equal to, when you look at the right hand side, a is common. So when you take the a common out, you get r to the power of n minus 1. So again, we will write this expression. So equation is Sn is equal to a times of r to the power of n minus 1 divided by r minus 1. So therefore, we have actually derived the formula. In order to find the sum of a geometric sequence, use the formula Sn is equal to a times of r to the power of n minus 1 divided by r minus 1. So we will actually use this formula when r is less than minus 1 or r is greater than 1. And there is also another alternative formula we use if the r value is between minus 1 and 1. Therefore, we use this formula Sn is equal to a times of 1 minus r to the power of n divided by 1 minus r when r value lies between minus 1 and 1. So let's again just do a quick review of this formula. So we actually first we actually write the series Sn is equal to in terms of general form, and then we actually multiply the same equation with r and subtract the two equations, and from here we get the formula Sn is equal to 8 times of r to the power of n minus 1 divided by r minus 1. So we can use this formula in the case when the common ratio is less than minus 1 or when r is greater than 1. And we also use an alternate form of this formula when the value of r is between minus 1 and 1. So the formula is Sn is equal to 8 times of 1 minus r to the power of n divided by 1 minus r. So let's do an example using this formula. So find the sum of the first 9 terms of the sequence. So how do we find sum of 9 terms of the sequence? The sequence is this, which is 0.25, 0.5, 1, 2, 4, and so on. So first of all, we have to figure out what is A. The first term is 0.25, and then we have to actually find the common ratio. So the common ratio is the second term divided by the first term. So 0.5 divided by 0.25, that gives you 2. So the common ratio is 2 here. So when the value of r is greater than 1, so when r is equal to 2, it means it's greater than 1. So we use the first formula, which is Sn is equal to 8 times of r to the power of n minus 1 divided by r minus 1. So it's always better if you actually write the formula and then substitute the values in. So finding the first sum of the first 9 terms, so n is equal to 9 here. So S9 is equal to 0.25 times it by 2 to the power of 9 minus 1 divided by 2 minus 1. So the sum of the 9 terms, just use a calculator. So we can further simplify 0.25 times it by 2 to the power of 9 minus 1. So 2 minus 1 is just 1. So we don't have to write the 1 in the denominator. So first we actually evaluate what is there in the bracket. Use your calculator. Type in the value. So find the value of 2 to the power of 9. And then you subtract 1 from it. And then you multiply with 0.25. So we get the value 127.75. So therefore, just adding up. So in this sequence, instead of just adding it up all the 9 terms together, we use just a formula which makes it much simple. So just using this formula, we have found that the sum of the 9 terms of the sequence adds up to 127.75. Let's do another example. So this example in here, we can actually see that there are 2 terms given. So the third term of a geometric, so instead of geometric sequence, I'll write it as GP. GP means geometric progression, which is just the same. So the third term is given as 11.25, and the sixth term is 303.75. So we have 2 terms given here, the third term and the sixth term. So the question is to find the sum of the 10 terms. Finding the sum of the first 10 terms. So first of all, when 2 terms are given, so especially when the third term and the sixth term is given, in order to find the sum of the first 10 terms, we need to know what is the first term and what is the common ratio. So we need to actually frame an equation using the general form or the explicit rule. So first of all, we will write, so T3 is equal to 11.25, and here you have T6, the sixth term is given. So T6 is equal to 303.75. So what we do here, we use this explicit rule, or we call it as the general rule. Tn is equal to AR to the power of n minus 1. So we actually sub in the value of n is 3 here. So T3 is equal to, we don't know what is A and R, so just write A and R as it is. AR to the power of 3 minus 1. So we are given that the third term value is 11.25. So in the place of T3, we sub in 11.25 is equal to AR squared. So we have the first equation in here. Likewise, we will actually frame an equation using the sixth term. So T6 is equal to AR to the power of 6 minus 1. So in the place of T6, the value is 303.75, which is equal to AR to the power of 5. So this represents the second equation. So whenever we have a geometric sequence where two terms are given, in order to find the first term and the common ratio, we actually use the explicit rule and frame to equation and then divide the second equation by the first to get the value for R. So divide 2 by 1. So divide the second equation by the first one. So therefore, the second equation is AR to the power of 5 is equal to 303.75. And the first equation is AR square is equal to dividing by 11.25. So we don't have to write the equal to here. Okay, so dividing the second equation by the first, AR to the power of 5 divided by AR square is equal to 303.75 divided by 11.25. So A divided by A is 1. So now we apply the index laws. R to the power of 5 divided by R square is just R cube. R to the power of 5 minus 2 gives you R cube is equal to, just use a calculator and find 303.75 divided by 11.25 gives you 27. So we have R cube is equal to 27. So what will be R? R is equal to, when you take the index to the other side, becomes the cube root. You find the cube root of 27. So that gives you 3. So the common ratio is 3. So now we have to find the first term. Substitute the value of R in any one of the equation, either in 1 or 2, whichever is easier for you. You get the same answer. So equation 1 is just AR square is equal to 11.25. So therefore we actually sub in R as 3. So 8 times 3 square is equal to 11.25. So therefore A is equal to 11.25. So 3 squared is 9. So you divide this by 9 to get the value for A. Use your calculator. So you get A is equal to 1.25. So therefore we have found the value for A, which is 1.25, and value for R, which is 3 here. R is equal to 3. Now what is the question here? So the question says find the sum of the first 10 terms. So therefore, in order to find the sum, we use the formula. So R is equal to 3. So we use this formula 8 times of R to the power of n minus 1 divided by R minus 1. So finding the value of the total of the first 10 terms, or the sum of the 10 terms. So n is equal to 10 here. So therefore, we'll write n as 10 and A as 1.25 times it by 3 to the power of 10 minus 1 divided by 3 minus 1. And therefore, 1.25 times 3 to the power of 10 minus 1. 3 minus 1 is 2. So use a calculator and evaluate what is there in the bracket. So 3 to the power of 10, and then you subtract 1 from it, multiplied by 1.25, and then you divide by 2. So you get 8,201.1. So the sum of the first 10 terms of this geometric sequence, where A is equal to 1.25 and R is equal to 3, you get 8,201.1.